Last class we have discussed about the indexing data structure. So basically the relational database model use the B plus tree indexing structure. B plus tree is a balanced tree. So there are two balanced tree, B tree and B plus tree. First, the B tree index is a balanced tree. Balanced tree, but all nodes have the same data structure. Each node has a number of children pointer as well as one less than the number of pointer, k minus 1, the key item. So each key item has the data pointer. How to organize such a thing we have learned about. Basically, in case of food, split into two nodes, then promote the middle value. In case of the odd number, it's obvious. You can select the middle number, then split into two. In case of the even number, so we are going to select the cardinal half, and the left-hand side will be the middle value, then split into two nodes. Okay? Then we can build the binary tree, balanced tree structure. However, still, it's not the B tree is not the perfectly balanced, because sometimes if you are lucky you can get the data from the root node. It's just one data node, the one IO. However, if you are not lucky, you need to get into the leaf node. Okay, so if you, in case the huge the indexing structure, sometimes 1, sometimes 1,000 maybe, so it's a huge difference. So in terms of the query optimizer that we are going to discuss next week. So in query optimizer prospect, so it's not balanced yet. So how can we address that problem? We are going to a little bit change the B tree, that is the B plus tree. B plus tree is all leaf node has the data pointer. Okay, so if you are search the data, you need to start from the root node and eventually get into the leaf node. Another benefit of the B plus tree is sibling pointer. So in case of the range query, we can utilize a B plus tree. What about the B tree? We can use a B tree for the range search 1 through 10, but you need to do up and down, up and down. Okay, that costs more the input and output IO. So that is the B tree index and B plus tree index. What about the real product? Such as the Oracle Informatics DB2 relational database model. They use exactly 100%, almost the same B plus tree indexing structure. Okay, so if you understand how the B plus tree index is organized, for example, after the last class, one of the students asked me, what if we have 10 or the 20 indexes? So we need to do the same process whenever data is inserted. We need to do such a kind of the operation algorithm, B plus tree indexing algorithm for each indexing. That may degrade the performance. Okay, so that is the reason indexing is not probably after graduate. So if you got the job as a database the programmer, so you prefer to use the indexing to search the data because it's a fast. It's a fast way. Not always fast. Sometimes the brute force way, linear search, sequential search is a fast search. Sometimes, not always, but usually using indexing is faster. So you keep asking the database administrator to create the index for this query, That may cause the performance issue later. Okay, so indexing is not always, but usually help to speed up your query. That is the indexing structure. So this week we will discuss about a little bit different topic, but it's an advanced topic for the database design. We have learned, first half of the semester, we have learned about what? Database design. So it starts from the information. This is the information. So from the information, what is the first step? Our goal is to build a database system. It has the database server and the client and something, the middleware, and eventually we will build such a database system. from the information, what is the first step that we have learned in this class?
Conceptual.
So conceptual model or logical model. That is ER modeling. Using ER modeling technique, we organize the information. The reason is that computer, if we just put the information about him, information about her, information about him, then computer can organize automatically all the information. No, computer is not able to organize automatically such an information. Computer can handle only structured data. Okay, in other words, formatted data. Okay, so information is not organized, so we need to organize conceptually. At that time, we don't have to worry about the computer skill. We don't have to worry about the application. Just organize. For example, student. To organize a student, I need the first name, last name, student ID. Using ID, I can identify the student. So it will be used for something key attribute to search the data. Okay? So we can make for that we will use entity relationship modeling. ER modeling is only for the relational database model. It's only for the database? No, it can be used for any other. Also, ER modeling is the only way to model the information? No, you already use the UML modeling, right? Or object-oriented modeling, something other modeling. Among them, we select the ER because the relational database model is very close to entity relationship model. Also, relational model is one of the popular database model. Anyway, so after ER modeling, conceptual modeling, or logical modeling, we learn what? What is the next step? ER is part of ER. Okay? In case it's more complicated, we can use the extended ER modeling. Then, what will be the next one? It's a relational database model. Still, this is far from the database computer stuff. So we need to get close to the computer, that is the relational database model. Relational database model. So which is based on relation, concept of relation. What is the concept of relation? It's a set. Set is group of elements. So why don't we consider the student of a group of students as one student concept, relation. That is the idea. That is different from the data structure used in other program languages, other computer science subjects. It's actually the very creative idea proposed by Dr. E.F. God a long time ago, 44 years ago, maybe, 1969 or 1970. Then, anyway, so using that one, we can design relational schema model, like the relational schema. So, and also it has something constraint, right? Can you remember that? The first constraint is each relation should have primary key. And second is it has the unique and non-null. And also it has the referential key, and so on. So we can build such a relational model. Using that, we can create the database. At that time, we need what? Software. What is the software? It's a relational database management system. For example, Oracle. Oracle is a software to manage the data based on a relational model. If you want, you can implement your own relational database model. There are standards. SQL 1, SQL 2, SQL 3, SQL 2003, and so on. So as long as you follow that standard, it will be your relational database management system. So by paying the very expensive money, so you can use, for example, Oracle, Informix, DB2, whatever. So using that, we can create a table by using structured query languages to utilize the resource of such a computer power. we need to communicate with the computer. So we need to have something program language. In database, so we have the structured query languages, so we learned a lot how to create. For example, creating database data definition language. Also, you can insert, delete, and select the data manipulation language. In first, second project that you are currently doing, you will implement some of the application, possible application, which is based on the menu-driven the database application. Select the SQL plus. Okay. So this is the overview of the database design. But we are going to, so our goal is to build, for example, university database. University database. So I collect all the information. Sometimes you can interview with your customers what information you need. Also, sometimes you can analyze the application program. So you need to eventually build a database model and database. Do you think? So if I order to build a university database, why don't you design the university database, then create a university database, then eventually university database system. Do you think the output of the university database are identical? No, I don't think so. Is there any general answer? General solution? No, I don't think so. Sometimes his database model is different from other. Each and every student may design different way, just like your exam answer. So it was tough to grade each and everyone. Okay, everybody complain. So I tried to generous, but not. I tried to keep my fairness. Okay, so it was very hard. Yeah, that's true. So output of such a database design, even application, is various. So do you think all of them? Yeah, sometimes all of them answer, but we can judge this database design is good, or sometimes this database design is not good, or bad, or something problem. Then how can you judge which database design is better than the other, better than others? How can you judge? At that time, you need to keep your mind objective. Goal of using database. Why do you use database? As we keep discussing, without database, you can use the information. You can use the data. Think about your program language, any other courses. Do you use SQL Plus? Do you use Oracle database in other computer science subject? No, you do not use. What about your computer? No, you never used such a DBMS. Then, what is the goal of the DBMS? Database. First, very large database. Then, when you have very large database, very large data, what's the problem?
It's hard to manage.
Hard to manage. It's a little bit abstract. What about details of the problem? It's hard to find the data. So when I had 10,000 students on the campus, if I do not know anything about your service, can I find a specific student who registered my... So it's not possible. It's the same problem in the database management. So if you do not have the specific model to manage the data, when you have the 1 terabyte, 10 terabyte data, so it's very hard to find the specific information. So that's the reason we try to use such a database. Sometimes using the foreign key, sometimes using the key or the candidate key, or sometimes you can join. So assessing the data very fast, that's our goal. Okay, then what is the other object? Easy to manage such a data. Okay? For example, my information as a instructor, my information is in the HR department. Also, it's in the payroll office. Also, it's in the computer science department. Also, it's in the School of Engineering. So I moved to new address. I got the new address. I need to inform each and every department where my information is stored. Okay, in case the data is not organized. Okay, in other words, so if you do not use such a DBMS, database management system, your data may be redundant or duplicate. Okay, so by considering two important goals of using database, one is accessing the data very fast. Another one is no redundant information. We can judge whether this design is good, whether this design is bad. Definitely, accessing the data is fast. Using your database model, I should be able to access the data very fast. That's the first criteria. The second thing is whether there exists redundant information or not. In case you have the redundant information, no, that's not a good database design. So today we are going to discuss about how to make the database design better and better. Okay, that is called database normalization. Okay, have you ever heard about the database normalization? So database normalization is the additional process. After you got the initial database design, we are going to normalize. Normalize means we will remove such a redundant information from the database design. So there are two ways of such a normalize. First, informal way. Another one is a formal way. What does it mean? The informal. What does it mean? Formal. Informal database design or informal way. What does that mean? Formal or informal? So it's a informal. It's a formal. Right? Yes. Because we are doing computer science subject. Actually, long time ago, computer science subject is part of mathematics. Okay? Then if we focus on the discrete, the function, discrete, the math, also computerized process, it is the new area of the subject. So computer science. But still, some of the computer science program is part of the math department. Okay? So when we are saying the informal way, or when we are saying the formal way, means whether this is a mathematical approach or formal approach. I'd like to say about the discussion with my daughter, Eunji. She is the 7th grade in the middle school. Actually, one of the favorite subject of her is the reading. And next is some social study and so on. She does not like the two subjects. One is physical examination, physical education. That's the kind of the athletic sport. Okay, she really hates the physical education. So, for example, she still does not know. So, do you know the baseball? Some of the people like the baseball. She still does not understand whether it's going to the clockwise or the counterclockwise. So sometimes in her school, she played the clockwise through the third base first. And she doesn't understand why so many colors are used in the sports team, like the Red Sox or White Sox and the Blue Jays and so on. And also another subject she does not like is the math. Then even she does not understand her daddy actually majored in the math. Then I'd like to explain about the math to her this way. So she likes the language art. She likes the reading. She likes the reading comprehensive. She read she read much more books than me. Really. So one of the big punishment of her is I will not buy any book for her. Then that's the biggest punishment. So I'd like to explain the importance of the math to her. At that time, I mentioned math is kind of the language. Okay? Why don't you go back to your middle school or elementary school or even high school, like the SAT or national? I think some of the country has a different formation of the nationwide exam system, like there might be college entrance exam in China, right? It's the nationwide. It's the same to me when I was a high schooler. So I need to take the just one time nationwide exam. If I fail that one, then I need to spend one more year to get the better. There's no extra chance. This is different from the SAT. SAT has you can take. It's kind of the bank of the question. Then randomly select some of them. You can periodically take. Anyway, so if you, right, do I mention that exam? Oh, anyway, so when I explain about the math to her, it's kind of the language. Okay, so yeah, if you go back to such an exam, one of the biggest problem in the math is the problem solving. Problem solving is, for example, there are two kids in the class, like Jane and Steve. Steve running 10 miles per hour, and Jane is running 8 miles per hour. But Jane is the 10-minute advance. She starts the 10-minute advance. Then where they are meet, something like that. Then at that time, how can you solve such a problem? You will make the equation, okay? Using unknown variable x and y, you make the equation, then solve that equation. So math is nothing but the language using mathematical terminology, unknown variable, and equation. So exactly same. It's a different language, okay? So that is the math. So computer science is actually part of such a math. So when we explain, when we define such a problem of the computer science, what is the problem in this class? How to manage big data, very large database, how to search the data very fast. That is the problem. At that time, we need to define, we need to explain such a problem formal way. That is mathematical terminology, using math equation. Math, the symbol. That is the formal way. That is the reason many of the textbooks. First, definition. Definition of a database. Database is letter D, large D, and it has, for the relation, has the D, then it has R1, R2, R2, and R is, such as R is the relation is blah blah. Then next the theorem. Theorem is A, if and only if B, something like that. This is the formal way. Okay? If you are in the graduate level class, you should be able to explain such a problem. You should solve that problem using mathematical terminology, especially PhD students. However, I know sometimes it's very hard to understand such a mathematical formal way of description. Okay. To address the problem, sometimes the textbook use informal definition, informal description. So it's the same thing. We are discussing about the goodness, how much good of your database model. At that time, first we will discuss about the goodness of the database design, informal way. Second is formal way. We are going to use mathematical way to explain about the goodness, how much good your database model is, using such a mathematical way. That is a formal definition. So if you try to write a paper, publish the paper, or write a textbook in research, academia, definitely you should use the mathematical terminology, formal way. One, standard. It's kind of for perfectness. So, for example, A plus B is equal to B plus A. Okay? How to explain informal way? You can change the two number for operation plus. So for example, 1 plus 2 is equal to 2 plus 1. 1 plus 3 is equal to 3 plus 1. 10 plus 11 is equal to 11 plus whatever. What about 1,000 plus 2,000? Yes. What about 10,000? You should forever. Sometimes I'm not sure whether that's correct, changing. So, to address that one, this should work with any case. At that time, you need to prove this one using mathematics. So, mathematics, formal way is perfect. No exception. However, informal way is easy to understand, but we are not sure whether this is correct for in every case. So sometimes work, but who knows? It may not work with a huge number or a smaller number. Okay? So that is the reason if you have new idea, you need to prove your idea using mathematics. However, sometimes the mathematical way, formal way, is not always possible. So sometimes we can prove our idea using simulation. For example, network. I have a new network topology, new network protocol. So can I prove the new network protocol using math? If you can do that, yes, that is the best one. But however, it's not possible to prove mathematical because there are a lot of variants, like the distance or the noise. So at that time you can use simulator, like the NS2 or whatever. Also sometimes simulator. For example, I have a new idea of scheduler in operating system. I think that this time you may learn the scheduler, CPU scheduler in operating system class, right? No? Who is taking the operating system? Nobody. So probably if you take the operating system in the next semester, this time you may learn the CPU scheduler. So I have new, it's not first in, first out, it's not the, what other? Scheduler algorithm. P4. So you are taking the course, right? So there, I have a new idea. Well, how can you prove my idea is better than the first in, first out? If you can prove the mathematical way, that's it. However, it's not possible, so at the time you can simulate. Do I need to implement a new CPU register and operating system to test my new idea? Nobody invests the money. At the time you can do the simulation. Simulation or sometimes the experiment. So in my case, in my research, I prefer use the experiment. So how much accurate? For example, from the video, I try to identify whether this person is a male or a female. Sometimes it works, sometimes not. So 70% accuracy. That is based on experimental result. So experimental result is another way. But best way is still math. Math is the best way. So that is the reason we are going to discuss about such a good needs of the database model using informal way, formal way. Informal way is a very, I already explained everything. So first, do you think what is the best way of the database design? Mathematically. So you don't have to use mathematics because we are discussing about the informal way. Just explain. Yes. What will be the good and what will be the bad example of the database design? There was an answer before while I'm explaining this one.
Following the method?
Following the what kind of method?
Relation.
So you are the instructor. So you will check whether this design is better than this. How can you? What will be the criteria?
Access
Read and redundant.
access data and redundant.
Redundant information. Okay? Database designer, database modeler, database administrator, they really hate any redundant information. Why redundant information is the problem? Redundant, if you have the redundant information, you need more storage, right? Definitely. If my name is in the department, the HR, yes, it's a 10 byte. Here, it's more 10 byte. Here, 10 byte. That's okay only for me. What if you have 10 millions of customers? 10 millions times 10 byte, huge. Okay? So no redundant information. That is the first criteria. When you judge whether this model is good for this one, no redundant information. So how can you keep the no redundant information?
Maybe a unique field.
Unique is a similar.
Reference.
Why don't you? So for example, in this room, I have student. Also, I have student. But I have graduate student. I have undergraduate student. I have non-computer science student. All of them are student, but it's a different student. So it's very hard to manage the student activity because I have the undergraduate student, graduate student, even non-computer science student. What if we have only one group of students for each room? So this room is for undergraduate. This room is for graduate. This room is non-computer science. That's much easier to manage. It's the same thing in the database. After you model, this is a relation. This is another relation. This is a relation. This is the student. This is the employee. This is the staff. Something like that. So if each relation has only student, this relation has an employee, this relation has a staff, that's good. However, if you mix them all together, that may cause the problem. So if you have one meaning of relation, for each relation, if you have only one meaning, that at that time you can avoid redundant information, right? So extreme case, you create only one table, one big table for university. Then put all together into one table. Like if you are not using the database system, just create the one notepad, text file, and type everything. Okay? It's easy to model.
No.
Yeah, it's easy to model, only one table, but it has all the information. So, for example, for student, I need a GPA, but GPA will not be needed for the employee. For employee, you need the social security number, which is not necessary for the student. So, if you keep all the information into one room, sometimes this is a null, it's a waste of space, and it's a redundant information. Okay? So, first guideline, or informal way of goodness of the database is one meaning for each relation. Okay? One meaning. This is just a simple way to judge. So when I see your answer from the data, the exam, so I'd like to see whether this is each entity, each relation has represent only one meaning. Okay? Sometimes the student combine employee and student. That is the graduate assistant, GA. Okay? If that is a requirement, yes, you can put into one because it's a one meaning GA. But if you have the student information, if you have employee information, you need to separate. Okay? That is the first guideline. And second guideline is what if
Relationship.
So I have student information and also department information. So I decide to use one table, one relation for this. Okay? First, it's the first guideline, one. One meaning for one table. Doesn't follow this one even. Okay? However, I decide to use this, the student plus department. Then, all student attribute. From this is all department attribute. For example, D number, D name, and so on. It's a student number and student name and so on. When I insert the data of the student, okay, without department information, can I insert the data into table?
Yes.
If this is not the key, yes, you can. But who knows? There might be. So we decide this one and D number plus the student ID as the primary key. Then we cannot insert the data into the table in case, like for general subject. So you do not belong to any department. Okay, so general subject without major. So you cannot create such a data. That is called insert anomaly. It's a problem of inserting. So similarly, we have the anyway data like this. We decide the remove computer science subject, computer science department. If I delete computer science from this table, all students who belongs to computer science will be deleted. So that's not what I want. So that is called delete anomaly, delete problem. What else? Update. When you update the department name, you need to update how many times? Number of times. Because student 1 has the CS, student 2 CS, student 3 CS. You need to update all the data, not one time, all the tuples that belongs to this one. That is called update anomaly. So, why? Because this table is not designed very well. It's a duplicate data, redundant information. That is called insert anomaly, delete anomaly, update anomaly. If your design course makes such a problem, we can say this is not a good database design. That is the second guideline. No anomaly. Like the insert, delete, update. Actually, it's the same meaning. One table, one meaning. If you have the multiple meaning of the one table, that's cause the insert, delete, and update anomaly. The third guideline is, what if, in this case, so this one, we decide to use one big table for all information. Sometimes we do not have the information about this, so we can use null. When you create, when you insert such a null data, do you think the DBMS does not use any space to keep the null data? Anyway, there might be some data will be used to represent null data, like the null pointer. Null pointer does not mean nothing. There might be something pointer, like in C language to represent to identify the end of a string. You can use a null pointer like this. Anyway, this null data will use the space. So what if you have a bunch of the data, 10 millions of null data? It requires certain space. So it's a waste of space if you have many null data. So third guideline is when you design the database, as less null as possible. It's not possible to design null-free database, but as null as possible. That will be the better database design. That's the third guideline. Another one is join. It relates to the join operation. When you join the database, what is the join operation anyway? Join? Yes, combine. What is the, anyway, so what is the most important feature of the relational database?
Key.
So relational database, we use the relation, set, group of data. So we can keep the same meaning of the data in one table as we have seen just before. However, sometimes we'd like to access the information for student and department at the same time, but they are scattered. They are in the different table. Like this room is for undergraduate, next room is for graduate student, but I'd like to announce the midterm exam schedule. How many times do I need to? So I need to announce here, I need to announce there. Okay? That is so to address such one, we need to combine two different rooms, two different tables. That is join operation. However, join operation is very, very expensive operation. What does that mean, expensive? It requires resource, more resource, higher risk in terms of memory, in terms of space, in terms of CPU time. Okay? When you think about the join, so if I ask you, why don't you implement the join? How can you implement the join? You need to access the data from employee. Then find the same data from department, right? When you join DNO is equal to D number, join and employee and DPT. How can you implement it? This one. You can get the day, access first data employee, then find the same data in the department. At that time, you can compare two data using this one. Vice versa, you can first access department number at department, then find the employee who satisfied this one. Or you can use memory, then put together all the information, then sort whether they are same or not. There are a bunch of ways. We will discuss such different ways in the next week in the query optimization and query process. Anyway, so this is the join operation. However, why don't you go back to your midterm exam. In your midterm exam, sometimes you can compare project and employee directly using D number. DEMP has a DNO and project as DNO. You join directly. You can join. However, that means we do not have department project. What if there is no department? Still you can join, right? But we cannot guarantee whether this DNO, control department, and DNO, who works for this department, whether they are the same or not. So if your design is not good, sometimes it may cause, it looks like the same department number. In our case, it's okay. However, if your database design is not so good, then when you join the department number, it may cause unexpected data. Okay? So in other words, it's called the spurious data. So it's a suspicious data. If it has unexpected data when you join, that is not a good database design. So if your design is perfect, So that is the reason this time I'd like to use the department. Then join this one and join this one. But I gave the credit for those who do not use the department version, because output is the same in this case. Anyway, so we have discussed about the 4 guidelines. First, one meaning for each relation. Second, no anomaly in case of update, delete, and insert. Third one is as none as possible, because it's a waste of space. And join operation when join will not cause any unexpected data. So if you join, if your join operation produce any unexpected data, that means your database design has a problem. So this is the just guideline in the relational database model. So everybody can understand. So that's the reason you already design. So relational database model and relational database design is not very difficult. Okay? However, these informal guidelines cannot explain each and everything. Okay, sometimes very complicated, sophisticated case, very complicated case. So to address that one, we will discuss exactly almost the same thing, but using mathematical term. That is a formal definition. In other words, definition of the goodness of the database design, or is called normalization. What is a normalization? What is a normal? It's not abnormal. What is normal? Average or kind of standard. So we'd like to make such a standard form of database design. That is called normalization. What will be our goal? What is the goal of our discussion today? Goodness. We'd like to make the better and better database design. How can we judge whether database is good or not? How? No redundant information. How can we make the no redundant information? Searching. Usually, redundant information causes the problem, right? Redundant information means all different information are in one table, right? We can separate them. That operation is called normalization process. Normalizing. So normalization is normalizing. So normalizing means it's a segment. Sometimes it's called a segment or split or the segmentation. Decompose. Whatever the name is, it's the same name. Decompose, normalizing, or the split segment, which means separate. Okay? Then it has the level. First, unnormalized data. Unnormalized data means the data and information in one big table. It's not normalized, it's not modeled. So we collect all the information. Definitely that causes redundant information problem, right? It doesn't obey given guideline. Okay? So we need to solve that problem. How can we solve? Normalize, or segment, or split, or decompose. Anyway, we need to segment, chop our group, all students, divide by something. Depending on something, depending on the criteria, depending on the rule to segment, we can have first normalization form, then second normalization form, then third normalization form, then BCNF, then fourth normalization form, fifth normalization form, and so on. What is this?
Grouping.
Grouping. What is the formal name of this? set Venn diagram, right? It's a Venn diagram, so it's easy, when using the Venn diagram, it's easy to represent the meaning of what? The relationship of set, okay? Can you remember that? Set A and B, this is A intersection B, this is A union B, and this part is A minus B. It's a Venn diagram, right? Can you remember that? This is a Venn diagram. What does that mean? You unnormalize include first normalize. It's getting strict and strict rule. In other words, if we have the third normalization form, that is unnormalized. First, second, already. So we will discuss about how to make first normal form. From unnormalized is obvious. You can put all the information into one table, one room. That's it. I will collect all the information, all people in the University of Bridgeport into one room. That is unnormalized. There's no rule, there's no classification. Yes, there might be one.